Welcome again to another opportunity to learn the topic sequences and series. We want to see how to solve this problem we have on it. A GP has a common ratio of 2. Find the value of n for which the sum of 2n terms is 33 times the sum of n terms. Find the value of n for which the sum of 2n terms is 33 times the sum of n terms. So this is a word problem on sequence and series. So for us to solve it, since they said the common ratio is 2, and they are talking about sum of that is sum of a GP. That means since 2 is greater than 1, since the common ratio, which is 2, is greater than 1, we will be using Sn equals to a bracket r raised to the power of n minus 1 all over r minus 1. That is because 2 is greater than 1. Now, what we do is, they said, find the value of n for which the sum of 2n. This is the one of sum of n terms. So, sum of 2n will be S2n equals to a bracket r raised to the power of 2n minus 1 all over r minus 1. That is for the power of 2n. That is for this. Now, the question is that the value of n for which the sum of 2n terms is 33 times the sum of n terms. So 33 will be multiplying this equals to 33 bracket a bracket r raised to the power of n minus 1 all over r minus 1. That is it. So what we do here is we now simplify. What is our r? Our r is 2. Our r is 2. We now say that solve this. A will cancel a. This will cancel this. Our r is 2. We say 2 raised to the power of 2n minus 1 is equal to 33 bracket 2 raised to the power of n minus 1. So what we'll be doing here is we now say that this is something as 2n raised to the power of n minus 1 equal to 33 bracket 2 raised to the power of n minus 33. Opening of the bracket. So we got this from law of indices. So we say let 2 raised to the power of n be, let 2 raised to the power of n be, let's say k. We say k squared minus 1 equals to 33k minus 33. That will be giving us k squared minus 1. This comes the other side, minus 33k plus 33 equals to 0. So minus 1 plus 33 will be giving us 33k, will be giving us plus 32 equal to 0. Factors of 32 are 1, 2, 4, 8, 16, 32. So we'll be picking two numbers from it such that when we add, so this will be minus minus because it has minus plus. This is k. Then I will pick 1 and this. That will be giving me minus 1 and 32. Minus 1 times minus 32 will give me 32. Minus 1 minus 32 will give me minus 33. That means I will go by this. I will now say that k minus 1 equal to 0 or k minus 32 equal to 0. K equals to 1 or k equals to 32. So the question, remember we said 2 raised to the power of what? N, let it be k. We now say 2 raised to the power of n equals to 1. That is 2 raised to the power of 0. Because 2 raised to the power of 0 is 1. Then we also say 2 raised to the power of n because we say k is 32. And that k is 2 raised to the power of n. We say let it be equals to 2 raised to the power of 5 because 2 raised to the power of 5 is 32. Remember, we said replace k with 2 raised to the power of n because what the question asks us to get is value of n, not value of k. But you apply k here to be able to simplify what you have here. So at this point, n is equal to 0 or n is equal to what? 5. If you take n equal to 0 here, it's of no use. So we say n equal to 5. Because that is the value of n. When we put it, they will be equal. Thanks for watching today's video.